HR, remember.
Okay. So this is the first lecture on course of spacecraft propulsion. It is so let me start with some. Sorry, yeah. So at the end of this lecture, you will be able to define the spacecraft, what the spacecraft is, what is propulsion, and generally spacecraft propulsion. And you have to identify the various types of spacecrafts and their function. You will differentiate various types of propulsion and its application. Define different space, what is space, what is universe, what is galaxy, what we mean by solar system, what are those celestial bodies, and what the atmosphere and the standard atmosphere, and what is the composition of solar system itself. And now the composition of standard atmosphere. So these are some of the basic things that you have to grasp from the today's lecture. So just starting from the word spacecraft. So these spacecrafts are simply the vehicles, or they are mechanical systems. They are machines, crafts, which are designed to fly in our space, or in which are useful for the space flight. That is directly taken from dictionary meaning. And it is a vehicle designed to operate with or without crew. Some spacecrafts are fly with crew, means people, and some of them are crew without crew, in a controlled pattern with above the Earth's lower atmosphere. So what we mean Earth's lowest atmosphere, that we can see later. So spacecraft is an assemblage of systems like structure, payload, service modules, again electrical device, optical and communication units that form a functional system to fulfill the space mission. So this is why I'm asking you your background. Those who have good design knowledge on structure can handle this part. Then those who have good knowledge on electrical device will handle this portion of the spacecraft, and optical and communication system, avionics system, the radio system, all will be included under spacecraft. So this is the meaning of spacecraft. So all spacecraft except single stage to orbit vehicles can get into space on their own and require launch vehicles. These launch vehicles are rockets. Most of the time, we use rockets to send other vehicles. A rocket will give the, sorry, I'm coming. So spacecraft are used to for various purposes, like Earth observation. As you know, we have, I think, observatory satellites for communication purpose, for meteorology. Means meteorology here is for observing the weather forecasting purpose, for navigation purpose, for space colonization as well, and planetary exploration and transportation of human and cargo to space. So for this purpose, we use spacecraft. So these are some of known spacecraft, like Space Shuttle Atlantis, which again there is Orion. So these are some of the spacecraft. And if this is telecommunication spacecraft, and the Mars exploration spacecrafts are some of the best examples for this. So when we say spacecraft propulsion, then once we understand the spacecraft, then what does it mean by propulsion? So propulsion is a simple word. which can be with many other words like jet propulsion, rocket propulsion, spacecraft propulsion. We use it for many purposes. Okay, so when we say propulsion, it is from the word propeller. So propeller means forward or backward, and propeller means drive or push. Therefore, propulsion means push forward. So the force which pushes the vehicle forward is called as a propulsion. Okay, so that is the meaning of propulsion. And which the principle of Newton's laws of motion, which is the law of action and reaction, actually. This is third law of Newton, is the base for the theory of jet propulsion. So a propulsion system is machine that produce thrust to push an object forward. So you know what this thrust, what are drag, what are lift, and what are weights. You know the four fundamental forces for in the case of aircraft. እንደማየው ከሆነ የኤርክራፍት ባክግራውንድ ያላችሁ አልመሰለኝም። ኦኬ አንድ ሰው ኤርክራፍት ስትራክቸር አስናቀ ኤክሰፕት አስናቀ ሌሎቻችሁ ኤርክራፍት ላይ ያሉ የተለያዩ ፎርሶች የተለያዩ ፕሪንሲፕሎች እነዚህ how aircraft fly የምለው ላይ እንትኑ በቂ ያላችሁ አልመሰለኝም። ሜቢ ብዙ ስራ ሊጠብቀን ይችላል ብዬ ገምታለሁ። Okay, so ምን አለ when we say aircraft propulsion እነዚህ አራት fundamental forces አሉ። weight አለ፣ lift አለ፣ thrust አለ፣ drag አለ። So those four forces must be understood in the case of. So that for that case, I will provide you one book, especially those who have no background of aircraft. I will send you one book. You can easily understand what are those forces, what are requirements for the flight of aircraft. But yenya basic course aircraft propulsion አይደለም. It is the more of spacecraft propulsion line. They are different. Basically, aircraft propulsion and the spacecraft propulsions are different. Means in aircraft propulsion, aircrafts are operating within standard atmosphere. That they can get oxygen from the atmosphere itself. Okay, so in the case of spacecraft propulsion, this oxygen is not there in the space. Why it is not there? We will see those things. Okay, so because of that, we need a system which combines oxygen with fuel. Okay, means that is required. So the working fluid is accelerated by the engine, and the reaction is accelerated, which produces force on the engine. That is momentum conservation principle. It follows the momentum conservation. Now, what is the difference between jet propulsion and the rocket propulsion? That we can understand from this slide. In the case of jet propulsion, which is air breathing system, so oxidizer or air is pulled into front of the engine and compressed, then mixed with the fuel. Okay, fuel, and which fuel can be kerosene or other fuel, which is ignited, and the resulting flame is ejected out through, which provides a thrust to the aircraft. So that is for jet propulsion system. But when we come to rocket propulsion system, the engine uses or carries both fuel and oxidizer together because it works in the area which is away from oxygen. Oxygen is not available there, so that it carries oxygen as well as fuel together. So the oxidizer and the fuel are mixed in and ignited and extends hot gases which propels through the exit. You see here. In this case, it traps oxygen from air and burns the fuel. That many types of yeah, hello. የሰማችሁ ነው?
ይሰማል።
ኦኬ፣ ጥያቄም ካላችሁ መጠየቅ ትችላላችሁ በመሃል። ይሄ የሮኬት ፕሮፐልሽን ስንል ምንድነው? ፊውሉም ኦክሲዳይዘሩም በአንድ ኮንቴነር ላይ ሆኖ ነው የሚካሄደው። ቢኮዝ ከአትሞስፈር በወጣን ቁጥር ስፔሻሊ ከስፔሲፊክ አትሞስፈር ከወጣን በኋላ ኦክሲጅን የሚባል የለም። ስለዚህ ያን ኦክሲጅን ስለሌለ ኦክሲጅኑንም ፊውሉንም በአንድ ሲስተም ይዞ ይሄዳል። ሜቢ ሃይብሪድ ሊሆን ይችላል ኦር ዊዝ ሲንግል ካስት። አሁን ለምሳሌ እዚህ ጋር ስታዩት staged kind of liquid oxidizer, liquid fuel አለው እዚህ ጋር። ይሄ liquid propellant system ሲሆን ነው። solid propellant system ሲሆን ፕሮፔላንቱ መጀመሪያ ሲሰራ በካስት መልክ ይሰራል። ፊውሉም ኦክሲዳይዘሩም በአንድ ላይ ካስት ተደርጎ ይሰራል። ስለዚህ ኦክሲጅን ፍሪ የሆነ ቦታ ላይ ፕሮፔል ማድረግ ይቻላል ማለት ነው፣ ያለ ምንም ኦክሲጅን ማለት ነው። So this is the difference between rocket propulsion and the jet propulsion. So the main difference between the jet propulsion and the rocket propulsion is that in rocket propulsion the oxidizer carried with the vehicle, but jet propulsion oxidizer is the oxygen in the air stuck into engine of the plane. So these are the propulsion system. So when we say once we identify a spacecraft and the propulsion, then we have to define the spacecraft propulsion. So spacecraft propulsion is any method which used to accelerate the spacecraft and artificial satellites. Most spacecraft today are propelled by heating the reaction mass. This reaction mass is the burnet fuel, okay, and allowing it to eject out from back rear of the vehicle, which is called the nozzle. The back rear of the vehicle is having a nozzle which contains convergent divergent section in it. Okay, why it is convergent divergent? What is nozzle? We will see it later. So this sort of engine are called rocket engines. All current spacecraft use chemical rockets. Okay, here what we are talking is the type of fuel which we are using. Most spacecraft use chemical fuels, means this fuel is containing the fuel and the oxidizer together. These chemicals are either bipropellant or solid fuel. Okay? How bipropellant are used, then this will be another topic. We have topics which can cover this all. So most satellites have simple reliable chemical thrusters, which is monopropellant rockets. Monopropellant, this is also another propellant type which we use. Okay? Or we say it are resistojet rockets for orbital station keeping and the momentum wheels for the attitude control. The newer satellites have geo-orbiting spacecrafts, which are starting to use electric propulsion. So another, this is electric propulsion is also another method of propulsion. Okay, look, chemical propulsion, on that bipropellant and solid fuels are the propellant types, monopropellants, and then electrical propulsion system use electrical ignition system or electricity for the purpose of propulsion. So this is what we call spacecraft propulsion. Now let's go to some vast ideas like what is space itself. When we talk about spacecraft, space is one word. So what is space itself? So space is simply a boundless three-dimensional extent in which objects and the events have relatively position and direction only. It is, when we say simply space, it is boundless. We don't have exactly this is space, that is space. It is just a boundless three-dimensional. And when we include in modern physics, when we include time, it is space-time, four-dimensional object. So it is four-dimensional. So this shows a simple Cartesian coordinate system that contains x, y, z plane. Okay. X, Y, Z plane, simple Cartesian representation, but that cannot handle the definition of space because space is four-dimensional. So space is almost perfect vacuum. When we say space, it is vacuum, nearly void of matter and extremely low pressure. Okay, so it is not quite imputable, but have some gas, dust, other matter floating over it. So that we call it as a space. And then where does the space begins? Okay, now there must be some distinct locations where somewhere space will begin. Okay, because the nearby space is having a lot of carbon dioxide gas, nitrogen gas, other gases which are comfortable for human life are within on the surface of Earth. But when we talk about space, it is just a start from some point. Okay, it is not directly the space which we are living here. Okay, so there is the concept of space is considered to be fundamental here, because from our Earth-bound perspective, outer space is considered just at 100 kilometers above. By the way, at what altitude aircraft flies? Can you tell me, any one of you?
What aircraft?
Commercial aircraft, just commercial aircraft flies in the altitude of
30 feet, 30,000 feet, most of the time.
30,000 feet or 36,000 feet. Okay, that means what is that altitude in
troposphere?
ISI? Yeah, in kilometer, it is actually 11 kilometer is the most appropriate altitude in which most commercial aircrafts are flying. ምክንያቱም ሰምታችሁ ከሆነ ሌላ ሀገር የሄዳችሁ አላችሁ አይደል? እናንተ ውስጥ ከኢትዮጵያ ወጣ በራችሁ የምታውቁ
አለና
እና ምንድነው የሚሉት እነዚህ የበረራ አስተናጋጆች ስንት ላይ ነን ምናምን ነው የሚሉት?
አቴንሽን ሰጥቼ አላውቅም ማለት ነው። አክቹዋሊ አንድ ጊዜ ብቻ ስለሆነ
እና ብዙ ጊዜ እዚህ አልቲቲዩድ ላይ ደርሰናል። ለምሳሌ 37,000 ፊት ላይ ደርሰናል ነው የሚሉት። that means it is 11 ኪሎሜትር። ምክንያቱም አንድ ፊት ማለት ማን ነው? አንድ ኪሎ ሜትር ማለት አንድ ሜትር ማለት 3 ፊት አይደለም? ስለዚህ ልክ ነኝ?
Yeah.
1 meter means 3 feet. So 11 kilometer altitude ላይ ነው ማለት ነው። 37 feet ላይ ነው እየበረርን ያለ ነው ካለ that means we are in 11 kilometer from the sea level. Okay, it is just measured from the sea level. So for the Earth-bound perspective, outer space of the Earth is considered 10 kilometer. The scientist called Tedros von Karman, he discovered this thing based on the density of the matter on the space. He calculated the density, atmospheric density, and then finally he decided this 100 kilometer as outer space. Above 100 kilometer, there is even no oxygen. Okay, so that line is called Karman line. Okay, so Karman line is an imaginary boundary at an altitude where there is no appreciable layers to breathe or scatter light. Even we cannot see blue sky at that point. Why? Because if there is no oxygen, we cannot identify blue from white. So the blue starts to give white to black because oxygen molecules are not enough to identify the colors. So we measure a long distance. How we can measure long distance? Because on the surface of Earth, we can measure it with the use of meter or inch or feet or some other mechanism. Okay, when we go to space, it is very long distance that we cannot easily measure them with the help of these units. So for that purpose, we use light years. Light year, okay. What light year mean? 1 light year means it is the distance that the light travel in a year. As we know, light travel in a second, within a second, 300 million meter. In 1 second, light travels 300 million meter. So that we can calculate 1 light year means 3 times 10 to the power of 8. This is the speed of light. 365.26. This is 1 year, days in 1 year. And we have 24 hours in every day, and then 60 minutes per hour, and 60 seconds per minute. So that from this we can calculate 9.47 or approximately 9.5 times 10 to the power of 15 meter per year. In 1 year, light travels about 9.5 times 10 to the power of 15 meter. So this is the 1 light year. Whenever we talk 1 light year, then what we are talking is this distance. Okay, approximately 10 times 10 to the power of 12 kilometers. This is 1 light year. Okay, so how does Theodor von Karman suggested that 100 kilometers is the outer space zone? He used some aerodynamic equations, equilibrium aerodynamic equation. As I told you, this is from aircraft design principle. So lift is equals to half lift the CL max. Rho is density. Density as a function of here Z represents the altitude. Okay. So because density varies with altitude, so that density as a function of altitude times the surface area of aircraft times velocity square, the aircraft velocity square, which is equals to weight. Lift is equal to weight is for the level flight from the aircraft design perspective. Weight is equal to lift means maximum cruising level flight condition. From that, we can find density as a function of distance or altitude, which gives us 2 over maximum lift coefficient, CL max means maximum lift coefficient, times B square over weight means mg, mass times mass of the aircraft times gravity, or weight over surface area. So he used this concept to determine the outer space. From this perspective, he found some values at 50 kilometer and 70 kilometer. He identified for 50 kilometer altitude and 70 kilometer altitude. He changed the density. On 50 kilometer, he found 3 times 10 to the power of minus 4 kilogram per meter cube density. And for 70 kilometer, 8 times 10 to the power of minus 5. Well, this is very small numbers in terms of density, the air density. So further, he identified, actually he calculated for 0.3 and 1 coefficient of the maximum lift coefficient. So very rare or scarce air density he found. Finally, he considered 100 kilometers is an appropriate density for outer space of the Earth. So below that, it is under the consideration of area having some air, means air density. Okay, now እዚህ ጋር ግልጽ ሆኖላችኋል እያልኩ ያለሁት እዚህ አካባቢ የስፔስ ባውንደሪን አይደንቲፋይ የምናደርግበት ነው። ስፔስ ኢንድለስ ነው እንዳልነው፣ ግን እኛ ለተለያዩ ጉዳይ የምንጠቀምባቸው ስፔሶቹን ባውንደሪውን በምንገልጽበት ጊዜ ነው ይሄን እና ያን ላይን ዲማርኬት ለማድረግ ስንፈልግ ነው። ሶ አሁን የት ነው ደግሞ ስፔስ ኤንድ የሚያደርገው የት ነው? where does space ends? Okay, we considered 100 kilometer above the surface of Earth considered as the outer space. Then where it ends? This ብቻ ምንድነው የመንፈሳዊ ህይወት ያላችሁ ሰዎች እንዳይጋጭባችሁ የመሬት መፈጠር ጋር የተያዙ ነገሮችንም ይዞ የሚመጣ ነው። ስለዚህ በዛ ላይ ያለው ነገር ያለምንም ቅሬታ ሳይንሱን ነው የምንቀበለው ስላችሁ ምንድነው የሃይማኖታችሁ የራሳችን ይዘን ሳይንሱ የምለው ነው። እዚህ ጋር መሬት የተፈጠረው ከቢግ ባንግ ፍንዳታ ጋር በተያያዘ ነው የሚሉት። ስለዚህ ያ ቢግ ባንግ ፍንዳታ actually universe 13.8 billion years before universe እንደነበረና ከሌሎች ዩኒቨርሶች ጋር ተጋጭቶ ሄሎ ኦኬ እኔ ጋር running out of time የሚል ነገር ስላየሁት ነው። ኦኬ let me upgrade። ስለዚህ ምንለው ምንድነው on the basis of science only let's discuss. Okay, ያኛውን የራሳችን በራሳችን ይዘን ማለት ነው። ስለዚህ መሬት የተፈጠረው ከቢግ ባንግ ፍንዳታ ጋር በተያያዘ በመለው so the distance of the end of the observable universe, what we are talking here is observable universe. የሚገርማችሁ ኦብዘርቭ ማድረግ የማንችላቸው ብዙ እንትኖች አሉ። ግን አሁን በሰው ልጅ ቴክኖሎጂ የተለያዩ ቴሌስኮፕ ተጠቅመን አሉ የተባሉ የዓለም ቴሌስኮፖች ተጠቅመን የምናያቸው ዩኒቨርስ ያንን ነው ኦብዘርቨብል ዩኒቨርስ ስንል እንትን የምንለው ኔክድ አይስ ጋር አይደለም። This observability is not based on the naked eyes, but it is based on the new technologies. So with that, hello? Yeah.
ይሰማል።
ኦኬ ስለዚህ ያ ዲስታንስ በምንድነው ካልኩሌት የምናደርገው? በአንድ አመት ውስጥ 9.47 times 10 to the power of 12 kilometer light year ካለን 13.8 ቢሊዮን ላይት ይር ይሄን ካልኩሌት ስናደርግ የምናገኘው ማለት ነው 13.1 or 13 ጊዜ 10 to the power of 22 kilometer away from our beginning of ስለዚህ በዚህ ዲስታንስ ውስጥ ያሉትን ነገሮች ነው ያየን ያለ ነው ማለት ነው። So this is what we call some observable space. So however the universe is expanding, so measuring space is kind of very challenging activity for the people who devoted on these activities. So astronomers are trying to much extent to know about the universe. Anyways, universe ውስጥ ያሉ ነገሮች ምንድናቸው? ዳርክ ማተር፣ ዳርክ ኢነርጂ ተሰሙ ይሆናል። ብላክ ሆል የምንላቸው ነገሮች አሉ። There is a kind of supernova, or that supernovas are the creation of new stars. ሱፐርኖቫ ማለት ኒው ስታርስ ምክንያቱም በተለያየ ጊዜ አንዳንድ ስታሮች ከሌሎች ይሞታሉ፣ ሌሎች ይፈጠራሉ። ኮሊዥን ያደርግና ደግሞ ሌላ ስታር ይፈጠራል። that is called supernova. So እንደነዚህ አይነት ነገሮች አሉ። So please በደንብ እነዚህ ነገሮች ከኢንተርኔትም ከምንም በደንብ አድርጋችሁ አንብባችሁ ለራሳችሁ ተረዱና ይሄ እኔ በእኔ ኢንትረስት ያዘጋጀሁት ነው it is out of syllabus actually so then what is universe itself so when we call universe it is all of the space and the time and their contents including planets stars galaxies and all other form of matter and energy these are called the universe. So the Big Bang theory is the prevailing cosmological description of the development of universe. So when we call universe, the whole cosmic system of the matter and the energy, which contains Earth and the human being also as a part of the universe. Okay, so on the universe, Earth is a very small ball of rock. It is considered as a sand particle near on the ocean. ከዩኒቨርስ አንፃር ኤርዝ በምንወስድበት ጊዜ የአንዲት እንትን ባህር ዳርቻ ላይ ያለችው የእንትን ቅንጣት ታክላለች ነው የሚሉትና so earth is a very small among when we consider the whole universe okay so earth is the minute particle in the universe with rich and noble heritage because that is the only place for the living creature these days ከሌሎች አንፃር ስናይ ሰው አለ ወይም የተለያዩ ህይወት ያላቸው ሊኖር የሚችለው ኤርዝ ስለሆነ now once we understand the universe let's see galaxy so galaxies are some gravitationally bound systems of stars okay አሁን ደግሞ ምን ሆነ ዩኒቨርሱ ሰፊ ነገር ነው ወደ ጋላክሲ ስንመጣ ግን በየራሳቸው በግራቪቲ ፎርስ ባውንድ የሆኑ የራሳቸው የሆነ ሶላር ሲስተም ያላቸው የራሳቸው የሆነ ስታርስ ስቴለርስ ኢንተርስቴላር ጋዝ ዳስት ዳርክ ማተር እነዚህን በውስጡ የያዘ ፓርት ማለት ነው so many such assemblages are so enormous that they contain hundreds billions of stars በእያንዳንዱ ጋላክሲ ውስጥ ብዙ ስታሮች አሉ ብዙ እንትኖች አሉ like ለምሳሌ የኛ galaxy we call it as Milky Way galaxy is our galaxy so that within the Milky Way galaxy we can see our solar system የኛ solar system የMilky Way galaxy part ነው ግን billions of galaxies አሉ እንደገና okay so Andromeda galaxy is the nearest galaxy to the Milky Way galaxy actually. The Milky Way galaxy contains our solar system. So the nearest galaxy, another nearest galaxy is Andromeda galaxy. ብዙ ጊዜ ተሰሙ ይሆናል ማን ነበር አንድ ዶክተር አለ ብዙ ጊዜ ስለዚህ ነገር ሲያስተምር ሰማለሁ ከዚህ በፊት ደግሞ ፕሮፌሰር ለገሰ ወትሮ ልጆኜ በጣም ይከታተለው ነበር ተሰሙ እንደሆነ በኢትዮጵያ ሬዲዮ የሆነ የገቢ ምንጫችን ቡና የሚል ዘፈን አለ የምታውቁ ካላችሁ ሜቢ ጁኒየሮች ስለሆናችሁ አልደረሳችሁም ብዬ ነው እና ከሱ ዘፈን በኋላ የፕሮፌሰር ለገሰ ወትሮ ስለ ህዋ የሚያስተምረው አለ ስለ ህዋ ሳይንስ ልጆኜ በጣም በሬዲዮ ተከታተላለሁ ከሱ እና በቃ በስማም ብማር እንዴት ደስ ይላል ነው እያልኩ ነበርና ወደ ሜካኒካል ኢንጂነሪንግ በዲዛይን ከሰራው በኋላ ወደ ኤሮስፔስ እንዲዞርም የገፋፋኝ ያ የልጅነት ህልሜ የነበረው ነውና ለገሰ ወትሮን አረሰው መቼም ነፍሱን ይማረው እና ብዙ ጊዜ ስለ አንድሮሜዳ ስለተለያዩ ጋላክሲዎች ያስተምራል okay so these are some of the spiral nebulas of the Milky Way galaxy this shows even as you can see millions billions of stars within the Milky Way galaxy okay again in Andromeda also you can observe those similar conditions and this is the pink wheel galaxy M101 የሚባለው galaxy እነዚህ ሀብል ስፔስ ቴሌስኮፕ አዲሱ እነዚህ ነገሮች በጣም ክሊር በሆነ መልክ ያሳያል even the condition of the black hole currently እንዴት black hole እየሆነ እንደሆነ black hole ምንድነው የምለው we'll see. And galaxies are classified as elliptical, normal spiral, barrel spiral, and irregular. So when we come to our particular galaxy, that is called Milky Way galaxy, the barrel type galaxy, galaxy. So within that, how many galaxies are there in the universe? That is a nice question, but approximately 2 trillion galaxies within the observable space only. Okay, ስለዚህ በጣም ብዙ ነው ማለት ነው። So once ይሄን ካልን observable universe የምንለው ምንድነው የሚሉ ነገሮች ማየት ትችላላችሁ። እዚህ ዋን ቱ ዋን ይሄን ማንበብ በጣም እንትን ነው ብዙ ነገሮች ስለሆኑ ስለነዚህ ካልን በኋላ እረፍት እንወስዳለን። ትንሽ ታገሱና So this is how we can, because specific ያረኩ ነው ወደ ታች ይወረድና ወደ ራሳችን ጋላክሲ ወደ ሚልኪ ዌይ ጋላክሲ ስመጣ this is general universe ነው። እዚህ ጋር የምታዩት ፒክቸር በኦብዘርቨብል ጋላክሲ ውስጥ ያለው ዩኒቨርስ ውስጥ ኦብዘርቨብል ዩኒቨርስ ውስጥ ያሉ ጋላክሲዎች ናቸው። ከዛ ውስጥ እቺን ሼፕ ለብቻው እዚች ጋር ተወስዶ እዚህ ጋር ሳና አለች እዚህ ሚድል ላይ we'll see. So this is our Milky Way galaxy. What is the dimension of our Milky Way galaxy? That is what I want to tell you. Diameter of Milky Way galaxy is 10,000 light years, and the height is considered